This is a used Schwabi A4A that we have remanufactured and added many features to. One of them being a removable feed table. Quick lock. Integrated guard system for easy access. Here you can see the modular feed roll system we've added that actually mounts to the body of the machine. Modular in-feed and out-feed feed rollers. Independently servo driven on this end of the machine. Each set of feed rolls is independently driven. You can access the die heads are set up here. This is a slotted plate that moves up out of the way. Insert the die, slide the plate down, lock it in place. It's a 30 by 30 head for cutting. UHMW base plate to cut against. Locks in place, safety interlock so the machine can't run if the feed table is open. Feed roll pressure adjust here with a scale. Feed roll pressure adjust here with a scale. We've integrated touchscreen control for machine setup. Here you can see that we can put our die size. Currently we're running a 4-inch die by a 4-inch square die. We've asked for trim of 1/4 of an inch on the edge of the paper, on the edge of the material in the front and on the side. 1/4 of an inch between each cut, and that's both X dimension and Y dimension. Our material is 60 inches wide. Our rule height is 2 inches. Our tie top position is 2 inches. Our die bottom position is 550 thousandths. All of this is changeable on the fly. It can be done while the machine is running. We also have a pause mode that allows us to pause the machine at whatever operation it was doing. Then just push the start button and it starts again without losing its place where it was. One of the features we put on this machine is we've replaced the old manual movement system with a ball screw. This is a hardened ball screw. Servo motor to control the speed. It is variable speed. And XL, decel is all variable from the screen. We also control depth of cut electronically by sensing the position of the head. Again, in-feed and out-feed rollers are modular. This is the out-feed. See our curtain guard to cover that on the out-feed side. These guards have been removed for video purposes. Of course, they'll be reinstalled for running purposes. This end of the machine, see the completely covered drive area. Up on top is our hydraulics. It's all new. We actually increased the capacity of this machine by 20% by going from a 7.5 horse motor to a 10 horse motor. All new valving, new plumbing, and control.
What if we do nesting head?
Oh. On this particular machine, this is a fixed head, which means all we can do is cut and move. They do make a nesting head machine, which we're more than happy to do. In that case, what we would do is mount a servo motor onto the nesting head. We would cut, rotate the head whether it needed to rotate clockwise or counterclockwise. On this machine, when we set our nesting head controls, we can cut all the way across, rotate the head, cut all the way back, nested from the original set. We can cut, rotate back, cut. Depending on what we need to do, we can do a multiple of 2 and 2, 3 and 3, rotate every other row, whatever we need to do. We can also integrate vacuum into the head if needed. And that can be multi-position if it's required, whether we needed to do it in 90-degree increments or 180-degree increments. We can integrate that into the machine also. All of that would be controlled via the touch screen, would be integrated into control and saved in memory, so that setups would just be pulled out of memory and the machine would remember everything that we had in from the previous run.
And what were you going to show us over here?
Well, just the electrical control cabinet. We have freestanding electrical control cabinet. All of our ducting system over is completely enclosed. That allows free from vibration, so we don't have to worry about any vibration transferring from the machine into the control system.
And that's the overview of what's happened. Basically, that's why this is a Phoenix. We start out with something that's rusty and make it better than new.
Okay, we'll do a quick setup. We have a 4x4 die, so we're going to ask for a 4-inch wide by 4-inch long die. We want a 1/4 of an inch trim on the lead edge and a 1/4 of an inch trim on the right-hand side. Trim between cuts, we want to be a 1/4 of an inch. Our material is going to be 60 inches wide. Rule height is 2 inches. Our top die position is going to be 3, and our bottom die position is going to be 550 thousandths. That's all there is to set up. We're going to reset the counter to 0. When we say start auto, go ahead and watch the head, Nicholas. Head returns to 0, goes over to the start position. Turns on the feed rolls, waiting on material. Okay? We feed the material in.
Running, we're changing the actual stroke. This machine is currently rated for what, 50 tons?
About 50 tons.
About 50 tons. And yeah, we're getting some pretty fast speed out of it. Movement. Now, when we get to the end, why don't we pretend that we've got a 20 or larger inch die?
Actually, what we're going to do is something different.
Okay. What are we going to do?
We're going to change the trim between the cuts to 1 inch on the fly.
now we've got a short movement given that the die is the small size. But if we turn around and we tell it it's a larger die, the 5-inch a second acceleration on the head starts showing up because of how quickly. As you can see now, it's covering a much further distance pretty fast. So basically the top and bottom position, the high-low speed for the stroke itself, as well as the lateral movement are all programmable. And that's what the Phoenix allows you to do. Have all of your settings be germane to the die and the specific substrates that you're running. Now to see what this means in practice, what we're looking at here is we start out with 1/4 inch, we went to 1-inch gaps, 2 inches, then 4 inches, all the way up to an 8-inch
4,
matrix.
2, 1, on the fly.
Now, of course, this isn't a race car, and the idea is not to see how quickly you can shift gears, but what you are seeing is how readily you can make changes to suit your job. And when you finally have found the sweet spot, then you can turn around and memorize the job, and from then on you just automatically bring it up in every single attendant setting for the machine, whether it's the speed through the machine, the tension on the substrate, the matrix in between each cut, the speed of the head traversely, the speed of the head going up and down, the up position, the down position, all of which are programmable with unlimited job memory. Which is why this is the Phoenix. Starting out with a 40-year-old machine. Now this is a look at the control panel, just so you can see where we ended up with on this very last cut when we were running 8 inches in the x-axis. Oh, I'm wrong, 9. So this gives you a good idea of all of the different variables that are set, and of course this can be memorized by job and recalled as needed.
This particular one, we want to save it to run it later, so we go to our setup screen. We call it test 3. We say save the file. You see it appear here. We can pull up a previously run order. Let's say we want to pick test 1. We read the file. As you can see, the values here changed. We go over to the run screen. Now we have 4, 4, quarter, 9, 60, 2, 1.5, 550. Go over here. We select test 3, the one we just saved. We read the file. Now we have 8 and 8, quarter, 60, 2, 1.5, 550. It's that simple. Save all of our setup data and we're ready to run.
So once we get past the initial tests, this is what this baby looks like when it's sitting on your floor making you money. This is the Phoenix from Zinnovation. We can pretty much apply this to any hydraulic die cutter, or of course we can always build it new. By the way, the reason for the window there is in a normal mode, you're putting the die in, you can see through that, and usually the head will be on this side of the machine for die mounting. And there you go.